Hello, David here, and welcome to a tutorial on the advanced features of the Process Modeling Flow Editor in Visual Components, where we will build up a simple layout and extend it step by step to introduce the Flow Editor features. Let's begin by building up the layout. From the eCatalog, select Process Modeling Flow Components and drag a feeder process into our layout. Then add a manual workstation, which we will organize a little by rotating it 90 degrees, and then copy and paste it to add another, so we can create two parallel processes, and then drag and drop a sync process. And then from Machines and Visual Components, we'll add a parametric lathe that we'll also copy and paste until we have 3 in total. And finally, from the Basic Shapes category, we'll add a block geometry, and from its Component Properties panel on the right, we'll change its material to orange. We will use this block to represent our dynamic product, so that we can see where and how the products are moving. And now, with our basic layout ready, let's visit the Process tab, and from the ribbon select the Products Editor. And from the Product Type Editor panel on the left, we can see that the default flow group and component that came with the feeder process we added are already in place. So we'll select the VCCAN product, and from its Properties panel over on the right, using the Pick Component option, we will assign the orange block geometry we added as a dynamic product. And if we then select the Processes Editor from the ribbon above, we have a process group consisting of a single feeder. We have 2 manual processes, which also form a process group since they are parallel and use the same name. A third process group containing 3 parametric lathes, and a fourth process group containing a single sink. And if we now select the flow editor above, we can create the basic flow using automatic flow creation. Clicking the feeder label will add it as a new flow step with that process group, and selecting the manual process label will add that process. And the same for the parametric lathe, while the transport links are automatically created, and also for the sink. While the Process Flow Editor is active, to avoid changing your flow, avoid left-clicking on a label, unless you wish to use the automatic flow process to add it as another flow step below. And note that the preferred way to edit processes is by enabling the Process Editor, which will deactivate the Flow Editor and prevent any additional changes to your flow. Alternatively, we could add the processes to the flow by dragging a label into the Process Flow Editor, or by clicking the green plus icon on the right and selecting a process by name. So now we have our basic flow created, and you can see that each flow step has a handle above it, and clicking on that handle selects that flow step, and its properties will be displayed in the panel on the right, where we can see its name, an option to declare the step optional, and if there is one or more process groups in a flow step, you can select the process mode, such as first available or all processes in any order. And we will cover these options later. And if you want to reorganize the flow, select the flow step by its handle and move the step, or right-clicking will display options such as add, delete, cut or copy, and so on. And now you can also select processes or process groups and drag them into another flow step, resulting in an empty flow step. So as you can see, a flow step can now contain one or more process groups. And if we drag processes back and forth, creating empty flow steps, the flow will not proceed, because there are now no process groups for our product to move to. So in a basic flow, there should not be any empty flow steps. So now there is a difference with how you select and move a flow step, should you wish to reorganize your flow. And you can also select the process or process group inside a flow step and add multiple process groups to one step. How this works and affects processes we will go through in this tutorial. So now we have our basic flow, and if we play the simulation, we can see the orange block geometry move from one process to another, and following processing time, the products will move to the sync process. If we reset and run the simulation again, the product moves from one flow step to another. And now a flow step can contain multiple process groups, and we can add more process groups to an individual flow step. And in the default mode, if I select a flow step, for example the parametric lathe process group, you can see from its properties panel on the right that the process mode is first available process. If we then reset the simulation, and while the flow editor is active, right-click on the label of the parametric lathe in the center to edit that process. And in the routine properties panel on the right, rename it to lathe 2, which will create a new process group, and repeat that process for the third one, renaming it to lathe 3. Then closing both the process editor panels, we can see that we now have 3 different process groups. And if we run the simulation again, you can see that the product only goes to the first parametric lathe, since the other 2 flow groups are no longer part of the flow. And if we pause and reset the simulation again, and left-click on lathe 2 and 3, and drag them into the flow step, and then run the simulation again, we can see the process begin to use the first lathe, then the second and the third. So if the first parametric lathe is available, it will be used first. So this is priority order, defined by the order of the process groups in the flow step editor. And if we reset the simulation again and change the order of those groups, effectively reversing their order, when we run the simulation again, the first product should go to lathe 3, then to lathe 2, and then to lathe 1. And if we reset the simulation again and edit the manual processes, remembering to right-click on the labels when the flow editor is active, let's see what occurs if we change the delay values to something longer, for example 30 seconds, so that now the product is no longer entering the lathe processes all the time. And then running the simulation again, we should be able to see that no products enter lathe 1. So the first product enters lathe 3, and then lathe 2, and again to lathe 3, and then lathe 2, while no products enter lathe 1. So the products are still obeying the flow steps directly. They start from the flow step containing the feeder process, then proceed to the manual processes, and then in priority order to a lathe in the third flow step. And now let's reset the simulation again and select the parametric lathe flow step, since we have a second mode in a flow step. So currently the process mode in the properties panel on the right is set to first available process, and if we change it to all processes in any order, you can see that the appearance of the flow step will change. And now, when a product enters the flow step, it needs to enter each and every one of these processes in any order, although the priority order is still in place, as indicated by the order of the processes in the flow step. And if we run the simulation, we'll run into a problem, as the product enters the first process and based on the priority order goes to lathe 3 and is processed. And then we end up in a deadlock, because the product cannot move to lathe 2 or lathe 1, since there is no transport link. So we'll reset the simulation again and add transport links between the processes, resulting in all possible combinations. And running the simulation again, the product enters the manual process, then moves in priority order to lathe 3, then to lathe 1, and then to lathe 2, depending on which process is available. However, all products need to visit all processes listed in the flow step before they can continue. Now keep in mind that if the processes do not have buffer locations, this solution can easily result in a deadlock when there is a product waiting in all of the processes, so that the products cannot move from one process to another. And to solve this, you need to either use processes that are available to switch the product, for example, a process created with start transport ins and start transport outs, or you may need to limit the amount of products entering this flow step by using a before transport out in the manual process to check how many products are already in the next flow step. So now the product enters all of the processes in the parametric lathe flow step. And if we reset the simulation and use the properties panel on the right to switch the parametric lathe flow step back to process mode first available process and run the simulation again, the product enters one of the parametric lathes in the process groups in this flow step and in priority order. A common element of production systems are buffers, such as a shelf or conveyor buffer, used as locations for products as they move from one value-adding process to another. Let's now remove the additional transport links we added after we set the process mode in the Properties panel on the right to all processes in any order. And using the Select tool, we will select the 3 parametric lathes, and then using the Move tool, drag them a little to the right to make some space to add a buffer. Then from the eCatalog and in Process Modeling Warehousing, we will add a warehouse shelf. And use the Move tool again to refine its position. If the production flow should go through this shelf buffer before entering a parametric lathe, we could create a new process by dragging the buffer label into the process flow editor below. And notice the icons indicating that no transport links exist between the processes. So we could add transport links from the manual processes through the buffer and to the parametric lathes. And note that we don't yet remove the transport links we added from the manual processes to the parametric lathes, and we will explain why later. And if we run the simulation, the products will go to the manual processes, then visit the buffer, and move to the next process when it becomes available. So let's now reset the simulation, and using the Move tool, while holding the Control key, select each of the parametric lathes, and from the Component Properties panel on the right, edit the process time from 2 to 60 seconds. And if we now run the simulation and use the plus control to increase the simulation speed, the products will first visit the buffer and then begin to wait there. And if we run the simulation long enough, the buffer begins to fill up, since the 3 parametric lathe processes are a little slower than 2 manual processes. And resetting the simulation again, we now have a buffer in our flow. However, products will visit the buffer only when they need to go there, as they should move from one value-adding process to another as quickly as possible. And the reason we didn't remove the transport links we added from the manual processes to the parametric lathes was because we can select the buffer flow step and from the properties panel on the right, mark it as is optional. The appearance of the buffer flow step in the flow editor and the transport links surrounding it will change. And now, once a product leaves a manual process, if a parametric lathe is available, it will go there directly and will visit the buffer only if all of the parametric lathes are busy. And if we now set the simulation speed to, for example, times 10 and click play, the very first product enters the manual process and moves directly to an available lathe process. The second and third products should do the same, while the fourth will visit the shelf buffer. And while there may be the opportunity for a product to go directly from the manual process to an available lathe, since there are now always products in the buffer, the flow changes so that the buffer is emptied first, because the product has waited there longer, so its timestamp is older than a product coming from the manual process. So we now have a buffer added to our production. But what if we have batch production, where, for example, 20 products enter the system which we need to store and process before the next batch arrives? In that case, the product should visit the buffer first, and from there visit the manual process and perhaps return to the same buffer process before they can visit a lathe, if a lathe is available. So before that, let's make a couple of small changes to the layout. Using the Move tool, we will move the feeder process closer to the center of the layout, so it's easier to see, and the same for the sync process. And then selecting the feeder process again, we will use the Component Properties panel on the right, and in the Product Creator tab, change the feed mode to Batch, and select the existing product we have been using. Add a count value of 20 and an interval of 1 second, but the batch interval above we will set to 720 seconds. And if we now run the simulation, there is no change, as the products will wait in the feeder process. So let's reset the simulation again and change the flow a little. So let's drag the buffer process label from the layout into the flow editor, placing it between the feeder and the manual process. So our flow will now be from feeder to buffer and then to manual process. And although we already have the same buffer in the flow, we can choose not to set this new instance as optional. Instead, we will remove the existing transport links and create a new transport link directly from the feeder process to the buffer, and then to both manual processes. And you will notice there are now overlapping links from the buffer to manual processes, and from the manual processes back to the buffer, so that if the parametric lathes are occupied, the product can move directly from the manual process to a buffer. And if we run the simulation again, the complete batch visits the shelf buffer, and from there visits the manual processes to be processed as quickly as possible. And once the shelf buffer is empty, a new batch will be created. And later, the products move from the parametric lathes to the sink process. And if we then increase the speed of the simulation until the system is empty, and after 720 seconds or 12 minutes, a new batch arrives and is processed again. So in this scenario, we have the buffer process in 2 steps of the flow sequence. But you can define whether the steps are optional or not. So now we have completed our basic flow. We go from feeder to buffer to manual process to one of the lathes. And if the lathes are occupied, we visit the buffer to wait, and from there we go to a lathe, and from there to the sink process. And what then if we want to manage defects as part of a manual process? How can we get the flow to go from a manual process directly to a sink? Of course, we have the option of creating a failed product type with its own flow group and flow steps, including a manual process with change type. However, there is another option, since our flow steps are now clear steps and include their own properties. When we are changing the flow of a product inside a process, we can use 3 statements that can get, find and set. And from that step position, you can find a step, for example, finding a next step, or finding a step by name, or indexing backwards 1 step. And then, when you have access to a new flow step, you can set it back to a product. So we can create 3 statements that can get, find, and set flow steps to a product instance. So let's select the sink process in the flow editor, and from its properties panel on the right, name the step, for example, defects and sink. Now, while this name appears in the properties panel, it does not appear in the flow editor, as it will be used as part of a get flow step statement that we are going to use to manage product defects. So, to move a defective product from a manual process directly to a sink, let's first create transport links from the manual processes to the sink. As the amount of transport links has increased, it could be an idea to split the flow into 2 flow groups in order to remove some of the transport links. But in this example, it's still fine. So now that we have access from the manual process to the sink, in the flow editor view, we can now right-click on the manual process label to display the process editor panel. We transport in a product and save the product variable to product in. We change the process state to busy. We have a 30-second delay. And then we change the process state to blocked. And before we transport out, let's add a defect element in this process. Using the Statements menu available from the upper right corner of the Process Editor panel, we will select an if statement. And from the statement properties over on the right, create a uniform random value by typing in the condition field uniform. The seed is 0 and we randomize a value between 0 and 100. And if this randomized value is less than 10, we have a 10% chance. Then we do something, or else we don't change anything, and we transport the product out normally. And if the 10% chance occurs, to visualize the change, from the Statements menu, we will select Set Node Material, and from the Statement Properties panel on the right, change the material to red. So the product in of the arrived component changes its material to red. And now we need to get a flow step, so we can check in which flow step the product currently is. So now, with the set node material statement still selected, in the statements panel we have 3 statements to use. And the first we will use is getFlowStep. Now, while there are a lot of options available in these statements, we will only show a couple of them in this tutorial. The first thing is, what do we want to get? Do we want to get the exact flow step from our single flow group, and what is the flow step? And as you can see, the flow steps contain index numbers from 0 to 5. And the flow step name, where the default name is flow step, if you have not yet defined one. And here index number 5 is called defects and sync, the name we added earlier to the sync flow step. So in this example, we could select defects and sync, which gets the sync flow step. And using the statements menu again, we could add set next flow step to set the flow step to a product in variable. And how the information passes between the 2 statements is that we save the flow step as a flow info object, which is just a variable name. And in the set next flow step statement, we set that flow info object, the product's next step, into the product instance itself, and then it should move to the sync. We can do the same process another way. So if we right-click on the label of the other manual process to view the process editor panel, and then copy the if statement from the process editor panel on the left, select state blocked in the panel on the right and paste it there, and then delete the set next flow step statement. We could use the same getFlowStep, but we will change it to product's current process. So now it returns this manual process step because we are currently in a manual process. So we get the current step, and then we could use findFlowStep. And if you have a complex flow with parallel processes, you could find a flow step. For example, we have the flow info containing the current process, which happens to be this manual process. Then we could find a flow step. So for example, find next occurrence of a process group. And the process to find, let's find a sync. And do we search forwards or backwards? Let's set the search direction as forward. And there are a couple of other options, such as loop the search, skip optional processes, and so on. So now this saves the new flow step into the same variable. So we update the variable from the manual process step to sync step. And then, similar to what we did earlier, we use the statements menu to add the set next flow step statement again and set it back to our product. So the same end result, but 2 different methods. You get the starting position, you find and you set, or you can directly get a certain process and set that to a product instance. So now if we run the simulation, let's change the speed to ×10 first to run it slower. There should be products after processing that turn red, which go to a sync instead of going to a process. And here was one, and a second one. So 10% of the products are now defective, and we manipulate the next flow step for that product instance inside a process before we transport it out to a transport system. So now we have our flow complete. We have a flow built from flow steps. There can be the same process multiple times in different flow steps. Some of the processes are optional and are only utilized if the process or the first non-optional after them is not available, so then it is used. We have a flow step that is built from multiple processes, and these processes are parallel and are in priority order. So lathe 3 is always used first if it is available. And finally, in a manual process, we may manipulate the flow so there is a 10% chance of a defect, so that we interrupt the flow from manual process directly to a sync. So these are the advanced flow features. So the flow does not need to be linear, as there can be both optional and parallel processes, and you can jump from one flow step to another during your production.